It was Joseph Louis Gay-Lussac who experimented on the relationship between pressure of a gas and its temperature and formulated the what we call GAY-LUSSAC'S Law, which states that the pressure of a gas is directly proportional to its temperature at constant volume and amount of gas, which means that as the temperature of a gas increases, its pressure also increases, or as its temperature decreases, its pressure also decreases. Expressing GAY-LUSSAC'S law in symbols, P is directly proportional to T. Expressing this mathematically, this becomes P is equal to a constant times T. Simplifying, this will become P over T is equal to a constant. At constant, with the condition that it should have a constant volume and amount of gas. So, GAY-LUSSAC'S law therefore can be expressed as P1 over T1 is equal to P2 over T2. So we will now be using this formula to solve GAY-LUSSAC'S law problem. Let us now apply the formula in solving sample problem number 1. The pressure of a gas at 5.0 degrees Celsius is 15 inches of mercury. What will be its new pressure when it is heated to 60.0 degrees Celsius, assuming constant volume and amount of gas? To solve the problem, we're going to write all the information given by the problem, starting with P1 is 15 inches of mercury and T1 is 5.0 degrees Celsius plus 273, which will give us 278 Kelvin, while P2 is unknown and T2 is 60 degrees Celsius plus 273, which will give us a value of 333 Kelvin. The formula for GAY-LUSSAC'S law is P1 over T1 is equal to P2 over T2. Substituting all the values to the formula, this becomes 15 inches of mercury over 278 Kelvin is equal to P2, which is the unknown, over 333 Kelvin. Transposing this value to the other side of the equation symbol, we will multiply this by 333 Kelvin, also with this one. So that will not be changing the expression. So this will cancel. What will remain in here will be P2. So this unit will be cancelled. So the remaining unit is inches of mercury. So using your calculator, 15 times 333 divided by 278 will give you a value of 18 inches of mercury. Let us now proceed to sample problem number 2. A gas initially exerts a pressure of 2,100 torr at 393 Kelvin. What will be its temperature when its pressure becomes 2.45 atmosphere? So to solve the problem, we will write all the given information. So P1 is 2,100 torr and the temperature is 393 Kelvin. Pressure 2 is 2.45 atmosphere and T2 is unknown. So for the temperature, it's already expressed in Kelvin, so no need to convert. But the units for pressure should be the same. So I would like to express all the units of pressure to atmosphere. And I want you to do it at home. You will express all the units in pressure in torr. And I'll assure you, you will get the same answer. So this will be converted to, so I'll be using the factor label method. So torr will be at the bottom and then atmosphere will be on top. The relationship is 1 atmosphere is equivalent to 760 torr. So this will give us a value of 2.76 atmosphere. So we'll now proceed. We'll write the formula for GAY-LUSSAC'S Law. P1 over T1 is equal to P2 over T2. Substituting all the values to the formula, so this will become 2.76 atmosphere divided by 393 Kelvin is equal to 2.45 atmosphere over T2. So the unknown is at the denominator, so we'll do cross multiplication. So this will become 2.76 atmosphere times T2 is equal to 2.45 atmosphere times 393 Kelvin. So we'll transpose this to the other side. This will be over or divided by 3.76 atmosphere. Divide this by 2.76 atmosphere. So this will cancel. Okay, this unit will be cancelled. So T2 therefore will be equal to 348 Kelvin. Let us now solve problem number 3. A sealed storage tank contains argon gas at 20 degrees Celsius and a pressure of 780 kilopascals at constant volume and amount of gas. What will be its new pressure in atmosphere if its temperature is increased by 15 degrees Celsius? To solve the problem, we will first write all the given information by the problem, starting with P1, which is 780 kilopascals. And temperature is 20 degrees Celsius plus 273 will give us 293 Kelvin. For P2, it is unknown, and the temperature too is 35 degrees Celsius plus 273 will give us 308 Kelvin. So it's 35 because the temperature is increased by 15 degrees Celsius. So T1, 20 degrees Celsius plus 15 will give us 35 degrees Celsius. Writing the formula for GayLussacs Law will give us P1 over T1 is equal to P2 over T2. Substituting all the values to the formula, this will become 780 kilopascals over 293 Kelvin is equal to P2 over 308 Kelvin. We'll transpose this value to the other side, so we will multiply this by 308 Kelvin. We'll also multiply this by the same value. So this will become 1. So this unit will be cancelled. So therefore, P2 therefore will be equal to, the remaining unit will be kilopascals. So using your calculator, 780 times 308 divided by 293 will give us a value of 820 kilopascals. But we're supposed to express our final answer in atmosphere. So we are going to convert this value, kilopascals, to atmosphere. So kilopascals will be at the denominator, and we'll change it to atmosphere will be at the numerator. So the relationship is 1 atmosphere is equivalent to 101.325 kilopascals. So this cancel with this one, and the remaining unit will be atmosphere. And then using your calculator, 820 times 1 divided by 101.325 will give us a value of 8.1 atmosphere. So that's it. Thank you for watching, and subscribe now.